two, one. Hello everyone, welcome back to our YouTube channel, Becoming a ROS Developer. Today we have a presentation by one of our students, Ashish, who has completed a course, ROS 2 Navigation in 5 days. And this is a nice project where you can learn how to do autonomous navigation for mobile robots. And at the end of this course, you can complete a robot to implement this to implement this project and do autonomous navigation on a real robot on the Turtlebot 3 here at our office. So that's what we're going to be seeing today from Ashish. Hello, Ashish. Welcome back. How are you? Hello?
Yeah, hello. Hi, Rodrigo. I'm fine.
Hi. Excited to see your project now has to
Hello.
do with... Can you hear me? It seems like we might be having some connection
Yeah,
issues.
hello.
Yeah. Can you hear me? Yeah? Ashish?
Yeah, I can hear you.
All right, perfect. There's maybe a lag, so
Hello.
please go ahead and start sharing your screen and tell us what you've done today with your project, please.
Sure.
Okay, we can see your
I think you
screen.
can see my screen. Okay. So I have launched my real robot.
All right.
So the main of aim of my project is to navigate my Turtlebot uh, around this world. So I need to give few waypoints. I need to save few spots. So whenever I just call those spots, it should move to that spot. So the main goal is that.
All
So
right.
before that, to to make navigation possible, we need to make our map of our world, and then we need to localize our robot, and then we need to add our path planning. So we need to make give our planner to our robot so that it can follow that path. And also we need to apply few cost maps so that it can avoid few dynamic obstacles which are not there in static map.
Hmm.
So let me let me run my all scripts. So first I'm gonna run this localization node. So localization launch file. I'll show you 1 second.
Yes. Thank you.
So the reason I'm running this is in this I have included map also.
The map
So
server.
I'll just run both the nodes. One is map server. The map server actually provides the map which we have already saved in our project mapping folder. So it will just provide the map, and other node is AMCL node. So AMCL node used for localization of our robot.
Hmm.
And lifecycle manager. So lifecycle manager just manages all these navigation nodes which are like AMCL node or map server node or any other path planner nodes. All these nodes it can just manage to run, or we can also stop, or we can pause. So all these
Yeah.
kind of stuff we can do using this lifecycle manager. So it will just manages all these navigation nodes. So here we are using map server and AMCL, so that's why I'm using. So I'll directly launch these. So parallelly, I'll open my RVs.
That's a good thing that you separate Arvis from other things. Good practice.
Yeah, yeah. So I'll open my config file.
Also
So
good practice.
I'll go to my localization, or else we can also go to path planning.
Oh, okay.
In that, I'll take my config file, because later, however, I'll use my planners.
Yeah.
I'll launch my notes, planner notes also. So that's why I'm using this config file. So I'll just open that and we'll see. Yeah, I think the map is loaded. So
Okay.
let me localize the robot using this 2D pose estimate. So first, let us see where the robot is. So robot is currently is here, facing this direction. So I'll make sure same happens here also.
All right. So you're setting that initial post, and we see some things appear. Nice.
Yeah, I think now you can see that few particles were scattered around the map.
Hmm.
So these are used to localize the robot. So to get perfect localization, I need to just move my robot so that all these scattered particles comes into one direction and it will get localized. So I'll just move my robot. I think you can see here.
Uh huh. Yeah, we see you're twisting it. I found that twisting it both ways is the
Yeah,
best way to localize it.
yeah, yeah. So let's see the RVs. I think, yeah,
Much better.
yeah, it's managed somewhat. So actually, this map is a simulation map. So I think here you can see the offset of
Oh, it's a tiny bit
difference
smaller.
between
Yeah.
laser data and actual map data. So this offset comes in real world, because this map is not from real world. This is
I
normal
see.
simulation world.
I see.
So I think have no much problem about it as of now. So because we are not moving that extreme end. Okay. So okay, the localization part is done. So now I need to add my planners and my cost maps. So I'll just open my path planning and launch file in that
Mm-hmm.
planner.launch. So planner.launch contains all these nodes. I'll explain these nodes later. So let me just launch those nodes.
Yeah.
Yeah. So now I think planners also got initialized.
So sometimes, and you mentioned this actually, the cost maps aren't visualized.
Yeah.
So what I do to
Yeah.
make sure that everything's running correctly, I wait in the terminal until I see that managed nodes are active. Um, so it looks like it's not showing the cost maps, but that doesn't mean they're not
Yeah, yeah.
there. Oh,
Yes,
great,
manage nodes are active.
great, great.
Yeah. So when I have tested earlier also, it worked, because because when you see my map, which is static, like static map, there are no obstacles here in this area.
Yeah.
So when I go to real world, like I have one dynamic obstacle in this position, but my robot actually escaped from that obstacle and managed to go goal. So that I think only possible when you have cost maps, so that it can avoid any
Yeah.
obstacle which is not present in our map, static map. So I think
Correct.
in that way also we can figure it out, like does really our cost maps are launched or not. So
Besides,
it's simple, like
your whole
it's it,
path planning
it's
launch would fail if that
yeah,
was the case.
yeah, yeah. So it's simple that you just need to make sure that you keep any obstacle in front of your robot and try giving goal opposite
Uh-huh.
side of that obstacle. So let's you can see that robot is avoiding it or not. So if it avoids, then it's working super fine. So that thing we can just
Mm-hmm.
make sure. So now our main goal is to I have saved few spots. I can show you here. So I have saved few spots in spots file.yaml. So here you can see corner one, pedestrian,
Mm.
corner two. So if I call my service and if I want to go to corner one, if I give as corner one, say, so my robot will just move to corner one. So actually this is corner one, and this is pedestrian, and this is corner two.
Okay.
I'll just run. Uh, Give me a second. I'll just run it and show.
So you're launching the server that takes in those poses and converts them into navigation poses, basically.
Actually, I have created one service client,
Ah, I
which
see.
is sorry, service server, which is move spots to move. It actually saves all my spots using this. I'll just save my spots into YAML file. But now when I wanted my robot to go any specific goal which I have saved in my spots to file YAML file, so that I'll just do with my action client which I have created here.
Ah, okay.
So I think you can see here move to spot. So move to spot action client I have created here. Here it just take the data from my YAML file,
Oh,
and
nice.
it'll take the data of XYZ and orientation data which I have saved in YAML file, and it'll take the data and just it will just send to this topic navigate to pose. So it will just send as a goal. Just send as a goal, and so we can see in our uh, real world. Wait, I'll just show. So see here I've given as
Ah,
corner one, and my file name is spots file.yaml. So I need to give whole path. So just give me a second. So home,
I see.
user, ROS to workspace. From there I need to go SRC, and from there I need to go to project localization, because there itself my spots file is there. So in there I need to go to params folder. So this is the path of it, and I need to run my client. So I'll just make sure it is in project path planning, and my node name is move to spot. Yes, move to spot. So this is corner one. Okay, let me give as corner two, because corner two is
Uh-huh.
okay. Let me give as corner two, and I'll just start C. So we can see here robot is
Oh,
going to corner two. So yeah, uh,
nice. So,
yeah, navigation succeeded. So goal accepted, and my navigation is also succeeded. And when you see here also, when you see in our planner thing also, so there also you can see goal succeeded.
Oh, nice.
So this manages by our BT navigator, behavioral tree navigator. So that just prints you the goal is succeeded or not. So yeah, it's done. So let me give one other thing. So I'll take as corner one and let's see. See now I think you can see.
Oh, it gets really close to those obstacles, huh?
Yeah. Maybe I need to increase somewhat inflation.
Ah, yeah, that could be it because we just not just, but a month ago probably, we changed these obstacles and they're a little bit more difficult to deal with, especially for this because the inflation layer, it's only based on that little stick. So yeah, probably
Yeah.
that's a good guess.
So I'll just move to pedestrian and yeah, see.
Awesome. This is amazing, Ashish. Really nice.
It's so smooth.
Very smooth. Yeah.
Yeah. Yeah, again, navigation succeeded once again and same goal succeeded. Yeah, done.
Awesome. Could we see one thing just because it's
So
so interesting, Ashish? Could you show the
yeah.
spot, the saver of your spot service that you call it and then it saves it? Could we see that? Just to showcase.
Okay, you want me to save a spot?
Yeah, like save whatever spot you want, and
Yeah,
so we can see that because it's a
yeah.
really
For
nice
that, okay,
application.
yeah. So okay, I have one more file which is spots file. In that I
Ah,
have corner three, so I'll just remove this
yeah, yeah.
and we
Good
can save
idea.
here itself. We'll try that. So now I gonna try that. So let me just fix one position. So let's say this as corner three.
Uh huh.
Uh, this as corner three. Let's say. So I'll just move my robot somewhat back, and then we can save our spot. Uh, I'm moving robot back. I think robot is moving. Yeah. Yeah. Okay. Oh,
Perfect.
okay. Okay. So I'll save this as corner three. Let's see what happens.
So is that subscribing to the odometry or the AMCL pose?
No, my this file like spots to file actually subscribing to my odometric data.
Ah,
So I think you can see here. So it subscribes and it will also get updated every time because I'm using multi-threaded executor and return callback
nice.
group. So because I have both service and also a subscriber, which is post subscriber, so I'll just
Yeah.
make my service run and also post subscriber run both parallelly. So in one it will get save the data like post data,
Mm.
which is like my service callback, and another post subscriber callback is just to update my post data so that which I can access in my service callback and I can just save it. So
Mm.
that is just happening in this save spot callback. So it will just check that whatever name you give, it will just add into a dictionary and it will get just saved as uh, a position which you can access here. So once you enter end as your label, so whole thing like whole contents in our dictionary will just write in our YAML file. So it's basic logic, so simple logic, nothing more. So I'll just do that. So I'll just call my service. Sorry, first I'll just launch my service. So for that, I have my launch file, save spots launch.
Mm-hmm.
So I'll just launch it. So cd this is from localization. Yeah. Check localization. Save the spots. Yeah, save spots. So yeah, my node is initialized. So
now you have a service available.
yeah, I have service. A service. So now I'll just call my service. And 1 second. ROS2 service. Yeah.
I think you have to specify the type of service. I don't know if that's what you're. Oh yeah, you're doing that.
Yeah, that's what I'm doing. I think it's got stuck. I'll just do 1 second. ROS2 service call record. Oh. Yeah, record
That's what it's
spot.
called.
But I don't know why it's getting stuck.
It is strange.
Wait a second. ROS2 service call.
Do a list. Let's make sure it's there.
No, I'll do that. Okay.
Also, your internet connection, I can see, might be having some issues. Plus the camera. So if you want to lighten it, you can turn off your camera. That might increase your bandwidth.
I have bad internet connection issue. Very bad. So
maybe that's
where is that?
Record, right? Or save. So like at the bottom.
Record spot. Yeah, I have.
I
have record spot. I have. So I can just ROS2 service for record spot.
Oh, there we go. That seems better.
Yeah, now I got it. Okay, we'll do that. Okay, label.
So this is one tip. I noticed that ROS2 is a little finicky about this. If you open quotation marks and then start typing label, it does it better. So like do that and then L and then press tab.
Yeah.
I don't know the reason.
Yeah, I also follow the same thing. Yeah.
I like this better.
Yeah, because that part I don't know. I'll be confused always. So I'll take this as corner 3. So before that, I just need to mention one thing. Here, my node is initialized, but if you just want to here my node is started, but my data which is post data is not updated. If you want to see the data, it will just show as 0. So
I see.
Let me do one thing. I'll just move a bit backward so that you can see what I mean.
Right.
I'll just move backward and I'll just move forward. Now I think post data is updated because I have.
Yeah. Oh, there you go.
Now you see post updating. So this means that my node got actual post data of my robot.
Nice.
So now I can save it, because if I save earlier, it will get save as 0 all like XYZ as 0, orientation as 0.
I see.
So now the actual post is updated. So I'll just save my corner 3. Yeah, done. So corner 3 it's saved. So corner 3 has registered. Before actually getting all the contents in YAML file, I need to make it as end. Give me a second. I'll make it as n. So when I make n, now you can see successful spots file has been saved. So you can just see this. Previously I have deleted it and now it got saved corner 3. So let me do
Nice.
one thing. I'll just go to corner 1 and I'll come again to corner 3. So I'll go to here and I'll go to, oh, sorry. Yeah, okay. Not this. Hmm. I'll go to corner, corner 2. Yeah, corner 2. So it actually goes here and then we
Hmm.
can go to corner 3 and we can test it.
And then send. Ah, that's so nice.
Yeah, I think it's done. Yeah. Yeah, it's done. So now I'll make it as corner 3 and my file name is also get changed as spots file 1.
Oh, yes.
So I'll go to corner 3 again.
So it takes in any file you give it. Nice. If it has the
Yeah.
correct.
Yeah, because I have two files, spots file and spots file 1. I think it's
Yeah, sometimes the tolerancing
adjusting.
makes it go weird. It makes it do weird
It's
things.
adjusting its thing. Yeah, I think it's completed. Yes, it's navigation succeeded. Yeah, not to worry anything. So yes, goal succeeded. Yeah.
Awesome. Awesome. Great. So I think that's it, right? I think this covers the whole project.
Yeah. Yeah.
Awesome. Do you mind stopping sharing your screen and maybe turning on your camera back on? Maybe if we have
Yeah.
good internet, I think so. Just so we can converse
Hmm.
here face to face. Well, congratulations, Ashish. It's a really
Yeah.
nice project. So smooth. I know you worked hard on this one, and I just
Yeah.
want to say congratulations because it's so seamless. And I just want to remind everyone what was done here. So nav2, the nav2 stack on top of localization and map creation was done as a base, right, on this project to make sure you can do it. And then on top of that, Ashish created an application where you can save spots and then later use them. You saw with that client, you could just technically, and we saw it live. So you can just imagine the amount of applications that something simple like this can do with a little addition of something. For example, let me tell you this. Um, I've I have a a Roomba in my house, and I did the course ROS2 navigation as well. And you know, I'm a little bit of a tinker, so I added a Raspberry Pi on it and a lidar on my and a camera on my Roomba. So what I do is basically what you did. I made a map of my apartment, and I did the project to have some spots saved, and I can save as many spots as I want, like corner 3 of my house where I know I have, maybe I have a dog and I want to see if the dog is sleeping there, or maybe
Yeah.
I want to
Yeah.
see if what I use it for is to check if the thermostat, things like that. So I put a little camera that loops up to my things in my house, and I can just run it and take pictures. So what I do is I just take pictures, and I like to just see. You can think of these things as maybe security. Maybe you have a security robot that you need to take a picture of certain places at certain amount of times. Well, this you only have to take a picture service probably, and you'll be done. So that's really impressive what you've done, Ashish. I want to congratulate you
Yeah. Yeah. Thank
again.
you.
And I have a couple of maybe not questions, but since you're a pro already, you've done a bunch of our courses, and I can see the practice in the way you type almost. I have a couple of questions. So I noticed, first,
Yeah.
I have two questions. The first one is, why do you CD into the ROS2 workspace every time? So I noticed that in everything you launch, you first CD into it and then you do things. Is there like a reason or something?
I know nothing makes sense of making CD because launching you can launch from anywhere.
Yes,
So, but it's a habit for me
it's a habit.
because
Yeah, all right.
I'm working with ROS too. So whatever small change I make in my Python file, I need to build again whole thing
Yes.
because it's like converting into my executable node. So I need to build again the whole thing. So to build again, I need to make sure that it should be in my ROS to workspace.
No, so it's
So
like a habit.
it went into habit. So simple. That's it. Yeah.
Makes sense. Makes sense. Just so you know, though, for the future, I noticed you didn't do it, which is good. But a lot of people have the good habit. I think it's a good habit that makes sure your workspace is sourced. So I noticed you didn't do it because you probably know that it's already sourced. So we put that in the bash RC, so you don't have to worry about sourcing it. But once you
Yeah. Yeah.
start,
Yeah.
like I have 10 workspaces in my computer, so I always forget to
Mm-hmm.
source. So uh, it's good to have these habits to avoid
Yeah.
these things. So I just was curious. And the second
Mm.
point I wanted to ask is about this save record node. So
Yeah.
basically, in the demo, which was amazing, the demo that you showed us to
Mm.
save the spot, you told us, hey,
Mm-hmm.
let me move it back and then forward so the AMCL post is updated
Yeah.
and then save the spot. And once you
AMCL
saved
post.
it, yeah,
Mm-hmm.
once you saved it, we saw a really
Yeah.
small number, right?
Mm.
We saw like a 0, 0,
Yeah.
zero
Yeah.
point 0.2 because it was from the point that you moved on. So I guess I'm a little confused. Well,
Mm.
or maybe it's a comment because once you subscribe to the AMCL post, this will be with
Yeah.
respect to the map frame, right? So
Okay.
when you,
Yeah.
I think it depends on when you start mapping, for example. So if you start mapping, when you start mapping, that will be your 0, 0, 0, unless you go into the YAM
Yeah.
file and edit it. So
Mm-hmm.
my question is, I guess, why did you have to use odometry? Because if you have the AMCL post already and you're localized, oh, maybe because you
Mm-hmm.
didn't assume you were localized. You have to be localized for this correctly. You
Mm-hmm.
just
Yes.
subscribe to
Yes.
that. So in that point, the corner 3 that you did would be with respect to
Mm.
map. So it would be larger than 0 unless you started mapping right there. So I guess my question is, how does the odometry AIM-seal post kind of work together to provide this? Because you're sending a goal at this point that is very close to 0. So shouldn't it go to the map frame 0 instead of that point you sent it? Is that making sense? Is my question making sense?
No, I
All right, let me try. Let me
actually,
try and put this like this. When you send the navigate to post to corner 3, those
yeah.
values, are they 0, 0, 0, 0.1?
Okay. Mm.
Is that what happened?
Why zero? No, 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 not 0, 0, 0. Why 0, 0, 0?
Well,
Okay.
what I'm trying to say is when you recorded the third spot, the corner 3, right?
Mm-hmm.
It was a very small
Mm.
number, which meant that it was the delta of when you started running that save
Mm.
spot recorder. But
Yeah.
that position is not like with respect to map. It's with respect to something else. So once you send that goal, I saw it. You send it with respect to map. How does it go there instead of with respect to the map?
Oh.
I guess it's a hard question. It's a hard question, and I'm not formulating correctly. I guess I was a little confused on how you save the poses and then send a navigation post to it, because it's with respect to the map
Uh-huh.
frame. So if you turn on the TFs, you'll see where your map frame is. So when you send a goal 1 meter
Yeah.
to the right and you put 1x and the rest is 0, it'll go 1 meter to the right of that map frame you have. You see what I'm saying?
Okay. Yeah. Uh-huh. Mm.
So I didn't understand how corner 3 worked. So it was a very small number, and
Is
obviously
it
you
so?
didn't.
Wait a second. it is minus 0.6
Minus zero. Oh, minus 0.
minus 0.6 in x direction, and it's small number in y direction.
All right, so that's already with respect to map. Has nothing to do with odometry.
Yeah, minus 0.6 in x direction and minus 0.07 in y direction.
So then why'd you move
Because
it?
the pedestrian near pedestrian actual origin will be there according to the map.
So 0.6.
It will be considered as 0.
All
so
right.
It's just
And
going
you
up.
just moved it because otherwise the AMCL post doesn't update, right? Is that what you did?
Yeah.
Okay, I'm so
So AMCL post is just as 0 initially, because I have set it as 0. My pose is also set it as 0. I did not call it because my node is initialized, but it still did not call. I just moved a robot a bit so that my pose got updated once it got triggered, because I'm
Okay.
subscribing to my AMCL post, so it got triggered and my callback function got triggered so that my post got updated. So then it worked.
I understand perfectly now. Because you mapped in the pedestrian. You started mapping in that you're pedestrian. So that was technically your 000. All right, great. Sorry about that. That's a little confusing.
Yeah.
But that actually also shows, we know what we're talking, what you're talking about. So perfect.
So
Anyways,
if I did not move my robot, it'll actually, if I keep as corner 3 also, if it'll actually come to that pedestrian itself, because pedestrian has 0,
it's 000.
0.
Yeah, makes total sense because that's where you started mapping. What I do, just a quick thing, what I do, even though I start mapping somewhere, wherever, I always change it in the YAM. So it's at a corner. So I kind of like, in my mind, I can tell like, I can send goals like a little bit with more information every time I do it. But careful, because if you rotate the axis, then something with the cost map, with the global or local cost map, isn't adapted to handle that, so nothing works. So
mapping done at that position, because if you see the simulation, the robot will be started, like robot model will be started in pedestrian itself. It will be initially at pedestrian itself. So
yeah, makes sense. Okay, all right, great. Well then, that's it, Ashish. Sorry, went a little further, but I think these are interesting, and once it gets more complicated, it's interesting to look at. So thank you, Ashish, for showing us your presentations. Really, really nice, really impressive. It's a 10 out of 10 for me. So congratulations.
Thank you.
All right. So for everyone else that is watching, let me switch here to my face. I recommend you guys do what Ashish did here. So he's actually done the ROS basics for ROS 2 and ROS. And now he took the step to go into autonomous navigation. That's where you can use pre-made packages to build things on top, like we've seen here, and starting to come together to create actual great robot programs. So I invite everyone else that is watching to do what Ashish did here, and apply some autonomous navigation to your robots. So thank you, Ashish, one more time, and that is it from us. So we'll see you guys next time. We have one more presentation actually today, so we'll see you in a little bit. So thank you guys, and bye-bye. All right, Ashish, great. This was awesome.